In this video, we're going to introduce the type decimal for working with precise monetary amounts. Now, so far we've introduced floating point numbers, and you might look at a dollar amount or whatever currency you're familiar with as a floating point number. So for example, if I have $10.37, that looks like a floating point number because it's 10.37, just like when I write regular floating point numbers in Python. Now, floating point numbers are fine for most applications, but not all applications. So for example, if I'm taking somebody's temperature and it comes out to 98.5, that might really be 98.5732625959437. And the fact that there's all those extra decimal places is probably not that big a deal when you're simply trying to figure out, do they have the approximately correct body temperature at a given time. So one of the problems with floating point numbers is that they're stored in binary format, which is not a format that is compatible directly with floating point numerical representations, which means when binary representation of a floating point number is processed, it can only approximate the actual floating point value. And some floating point values can be represented precisely, and some cannot be represented precisely and wind up with infinitely repeating sequences of decimal places to the right of the decimal point. Now, when you start working with financial applications, however, to the penny arithmetic is extremely important, because when you start dealing with, say, billions of transactions, slight rounding errors can quickly add up to significant amounts of money. So for that purpose, there is a library that's built into Python that enables you to perform precise decimal arithmetic, and this is typically what you would use if you were performing monetary calculations in Python. So let's talk a little bit about floating point numbers again first, and then we'll introduce the type decimal. So let's say we go ahead and create a variable called amount, and we give it the value 112.31. Now, when I go and print out that value, let's try that, you can see that it prints out exactly what I had put in the first place. However, if you go and display that with some extra formatting, so let's again use an F string here, and we'll display the value of amount, and let's say we want to display 20 decimal places to the right of the decimal point in this case. So we'll go ahead and print that out, and now all of a sudden we see that 112.31 is not really 112.31, but rather 112.31, a whole bunch of zeros, and then a bunch more decimal points or decimal places after that point in the number. So this gives you a sense of the fact that in reality the floating point value is not precisely represented in memory, and therefore there could be rounding errors in certain types of applications that would be unacceptable. So with that said, what we want to do is introduce a new type. The type is called decimal, but it's not built directly into the language. It's built into the Python standard library. Now, the Python standard library is loaded with predefined capabilities, and so let's actually take a moment to pull up a web browser here for a second, and let's go to python.org. And when you go to python.org, again, the documentation tab has the documentation for the language and the libraries. So let's go to the Python 3.x documentation, and you can see once again the library reference. Now when you go to that library reference and you start scrolling down here, you're going to, after these first couple of seconds, you're going to start getting into all the different libraries that are part of the Python standard library, and you'll see that there's literally dozens upon dozens of these libraries of predefined capabilities that you can use in your Python applications. Now, I highly recommend that you take a few minutes to read through just this page to get a top-level sense of the sets of capabilities that are available to you, and it may also inspire you to go and dig deeper on some of these capabilities and possibly use them on your own as well. And by the way, there's tons of material out there that could help you get started with many of these libraries. Simply doing some searches on Google for tutorials, or on Bing, or whichever search engine you happen to use, will lead you to often the key capabilities that you need to use for a given library. So the library that we're about to introduce is the decimal library. Now, anytime you want to take advantage of a feature from a library, you need to first import that feature either in IPython interactive mode or into the scripts that you're writing. Now, for this particular example, we're going to introduce a form of input statement that starts with the from keyword. The name of the so-called module is what comes next. Now, each library that you want to use, if it's part of the Python standard library, may have one module name, but some of the libraries that we'll introduce to you throughout these videos will have multiple module names to choose from. So a library may consist of many different modules to organize a larger library into smaller subsets of features that you can pick and choose from. So from the decimal module, which is part of the Python standard library and therefore is guaranteed to be part of your Python installation, we would like to import a type called decimal. And by the way, notice that it has a capital D in it. So it's from the decimal module, I would like to import the type called decimal. Now, unlike when I go and create a floating point number up here, or an integer, or a string where there's built-in notation for those types of literal values in Python, with decimals you have to create an object of the type decimal. Decimal is actually a class, and then you can interact with and use that object. So I'm actually going to create a variable that we're going to use in a little bit later in this video, where we want to create a variable called principal, and it's going to be a new decimal object, and we're going to specify its initial value as a string piece of information. Now, it turns out that there are several ways to create decimal objects, but when you specify a string, it will convert that into a decimal numeric value that matches the value in the string precisely. So if you start from a floating point number that's represented imprecisely in memory, then you'll get that same imprecision as part of your decimal object. So for that reason, we typically are going to initialize decimal objects with string pieces of information. Now, when you evaluate the variable that we just created, the string representation of a decimal includes the type name decimal and displays the value in a string inside parentheses. And we'll talk about formatting decimal values in just a little bit here. So we're going to be doing some compound interest calculations in a little bit, which is the reason that we created this principal object with the initial value of $1,000. Now let's say we want to create another variable. We'll call it rate, which we'll use for interest rate later on. So we want to create a decimal object in this case that's going to represent 5% interest. So 0.05 is the way you would represent 5%. So again, we're going to create another decimal object, and when I display that object, you can see that its value is 0.05 at the moment. Now, when you're performing decimal arithmetic, you do that typically between objects of type decimal. So let's take a moment and declare a couple of other variables here. First, let's go and create a decimal object, and we'll give it the value 10.5. And let's create another decimal object, and we'll give this one the value 2. By the way, you can use any type of string as the argument to the decimal, what's called constructor, which is going to build the object containing the value that you specify. Now, when I create these two decimal objects, I can then use them in arithmetic expressions. So for example, x plus y is going to add these two decimal values. Python has built into it operator overloading, so any new type you create, you can also create special functions that will replace the functionality of a given operator for use with the new type that you're creating. So whoever was responsible for designing the decimal type also designed arithmetic operators to make it really convenient for you to use decimal objects once you've created them in your program. So as you can see here, it goes ahead and gives me the result 12.5. It added together the two values. Now we can also use the other arithmetic operators. So here we're going to use the whole number division operator in this case, and as a result of dividing 2 into 12.5, the result we get is 5, a whole number, because again this is going to give me the largest integer not greater than the result of dividing x by y. We can also modify decimal objects by using the assignment operators, or the assignment capabilities. Remember, they're not technically called operators in Python. So x plus equals y is going to add together x and y, but rather than modifying the original decimal object that x referred to, it's going to aim the variable x, or make it refer to a new object containing the result. So if I now evaluate x, you can see again it contains 12.5 in this case. Now let's take a temporary diversion over to a problem, and then we'll go back to our interactive session to implement what we see here. So what we want to do is take the principal, the $1,000 object that I created a few moments ago. We're going to invest that in a savings account that yields 5% interest, which is going to be the rate object that I created a few moments ago. And assuming that we leave all of that interest on deposit, we want to calculate and display the amount of money in the account at the end of every year for 10 years. So we're going to use a formula to do that, where the amount on deposit at the end of a given year is equal to the principal times the quantity 1 plus the interest rate 0.05 raised to the year power. N will represent the year. So P is the amount originally invested, N is the number of years, and A is the amount on deposit at the end of each year. So let me go ahead and switch back over to my terminal window. And again, we already created the principal and rate objects up above here, so we're going to use those in the calculation that we were just talking about. And we're going to implement a for loop that is going to iterate for each year in a given range. And in this case, we want to have 10 years, and we're going to use the numbers 1 through 10 to represent the powers that are used to multiply the quantity 1 plus rate, or not multiply, but raise 1 plus rate to the year power. So for this purpose, we're going to use a range function that counts from 1 to 11, which will give us 1 up to but not including 11, so 1 through 10 for 10 years. So with that said, we're going to then implement the formula that we just took a look at. So we'll use the variable amount here to represent the amount on deposit at the end of each year. We'll use principal to represent the principal, and we're going to multiply that by the quantity 1 plus the interest rate. And remember, again, we defined principal and rate up above. And we're going to raise this quantity to the year power, where year is 1 through 10 in this particular example. Now the exponentiation operator has the highest precedence here, after evaluating what's inside the parentheses. So first we're going to raise 1 plus the rate to the year power, then we'll take the result of that, multiply it by the principal, and get the amount on deposit at the end of a given year. Now, during each of those years, we'd also like to print out what that value is so that we can see the year value and the amount on deposit at the end of each year. So let's use an F string to display the year, and we're going to introduce some additional formatting in this example, and I'll explain it in more detail in just a moment. So we'll display the year, and we'll also display the amount on deposit at the end of each year, and for this one we'll add in some additional formatting as well. And again, I'll talk about that in just a moment. So let's go ahead and execute that, and you can see the year values 1 through 10, and you can also see the amount on deposit at the end of each year. And notice that we've got 2 digits to the right of each of the decimal points. Notice that the decimal points align as well. So let's talk about how we got that formatting in this particular case. First of all, the format specifier for the year, which looks like an emoji symbol, is actually greater than and 2. Less than and greater than mean left and right alignment respectively. So when you see a greater than sign and 2, what that means is we want to take the value of year and right align it in a field width of 2. Let me show you what I mean by that in a diagram for a moment here. So let's say we're outputting the value of the year, which and initially that value is 1. 1 is a single digit value, but if we tell it to display in a field of 2 right aligned, then the digit 1 gets placed in the rightmost character of the 2-digit field, and the leftmost character is left blank. However, when we get to year 10, we have a 2-digit number, and it simply occupies both field width positions. So in this case, again, it was an integer value being displayed in a field of 2 right aligned. Let's take a look at the amount, which is a floating point number. In this case, we wanted to right align this floating point value in a field of 10 characters with 2 digits to the right of the decimal point. So 10.2 is a field width of 10, so a total of 10 characters being used to render or display or format rather the numeric value in a string format, 2 digits to the right of the decimal point. So if I count backwards here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can see the full field width of characters used to display the first floating point value there. So the reason that we have columns of data here are the field widths that we specified. 2 for all of the years, which we right aligned in this case, and 10 for all of the amounts. And because we did decimal places with 2 digits to the right of the decimal place, and we right aligned all of those, they are aligned on the decimal places in this particular scenario. So that's an introduction to a little bit more of the formatting. And actually, let's just quickly take a look at another diagram here. So this is diagramming what I just showed you in the IPython session. So the 2 digits to the right of the decimal point are at the rightmost edge of our field width of 10. Then we have the decimal point, so that's 3 out of the 10 digits. Then we have the 4 digits that were to the left of the decimal point, so that's 7 out of the 10 digits, and all of the other leading character positions are simply filled automatically with spaces for you.